Hello, college algebra student. This video is for chapter 4.2, linear function model. So we're going to use linear model, this concept, to solve application problem if the question can be modeled linearly. So one of the question one of the things that we can model is when something change linearly when it's affected by another one's model change of a quantity, especially cost. So this is an example. The phone company has a monthly cellular plan where a customer pays a flat fee and then a certain amount of money per minute. So you're supposed to have a flat fee, and then for whatever that you use, you pay more, right? So, but what's the next? Okay, if the customer, but they don't tell you, they just, because they don't want you to calculate it, so they just say, oh, if you use 440 minutes, they quote that the cost is 244, and if you use 7 and 10 minutes, so maybe they just give you this two quote, the monthly cost will be 319. So underneath this, there should be a basic cost and a per minute cost. So we want to find the linear function that model this, assuming this is linear. Okay, linear function. And a lot of time it is within a certain range. So the way we do it would be to identify these two changes. So when the minutes change, it affects cost. So the linear function is y is the monthly cost and x is the minute. So x minutes affect cost. So we have two sets. This is one set where we can think of it as a point of 440. When x is 440, the cost is 244. This is y, x1, y1. And then another set would be this, 710 and 319. So what is the minute? Minute is x, right? X is y is monthly cost, x is minute. So it's 710. So don't mix up the number. 319. X2, y2. So now let's do the array. In order to do the linear function, we have to do the array. y2 minus y1, 319 minus 244. The two costs over how much change in minutes? 710 minus 440. So that would be equal to 75 over 270. If you use a calculator and simplify, is 5 over 18. So we like to make it, unless it's not simplifiable, if you can, you should use a more accurate number. And then we are ready to write the equation because we have 2 points. We just use 1 point, point slope. If I have the y-intercept, I can, but I don't have the y-intercept, I have to use point slope. So y minus 244 is a little harder. 5 over 18, x minus 440. And after you simplify everything, y minus 244 equal to 5 over 18x minus 5 times 440 over 18, right? And then for it to be a linear model, I have to add the 244 on both sides. Put in the calculator. So continue over here. So y would equal to 5 over 18x. Combine this together. It turns out to be, I did it beforehand, 121.78. Right, in the linear model, f of x is equal to 5 over 18x plus 121.78. Interpret the meaning of slope and y-intercept. Slope is rate of change of cost per minute, right? Cost per minute. So slope is cost per minute. How many dollars it is per minute. Y-intercept is when x is 0. So when you do not use anything, so that's the basic fee, right? Even if you don't talk, to get this plan, you have to pay this basic fee. Find the monthly cost if x 29 minutes are used. So x 29 minutes is minutes, so that's x. So that means I'm just going to do f of, I want to find cost, so that means I don't know the cost. Find f of x 29 using the model. 5 of 18, x 29 plus 120, what was it? 121.78. They're like funky number, not nice number, so it's harder. But if you multiply this in the calculator, 52.06, so it's $300, 352.60 cents or 6 cents. Next example is there's two linear functions and you are trying to compare them. So it is about home price, also cost, so house price. The median house price of two states, Mississippi and Pennsylvania, in 2 different years. We know that when year change, home price change, so this would be our T would be the input, and this home price would be the output Y, right? So this is for Mississippi, and then usually we do not use the year number as our T. We would say this is counted as T equal to 0, the initial number, and then this would be T 2000 minus 1950 is 50 years. So we have 2T and 2Y. So this is one set of data. And then for Pennsylvania, we have another set. We use the same T, but another Y, right? So this is for that. Which state increased at a higher rate? So that means they ask us to find the rate of the first one, Mississippi. Rate is Y2 minus Y1, right? 71400 minus 25200 divided by 50 minus 0. So put in the calculator. I did it beforehand, so it's 924. That means it's $974 per year, right? It's a rate. So year is X, or the input. So what about Pennsylvania's rate? So it's the same, but we look at this and the same T. So we would put 97,000 minus 42,400 divided by 50 minus 0. So we use the same T, and then if you put in the calculator, that is 1092 per year. So that is rate. So it is positive. Increase 900 for Mississippi, 10,092 for Pennsylvania. So which one is higher? So this is a higher rate. Pennsylvania's housing price, median housing price increased at a higher rate. What would be the median home price in Mississippi in 2010? So that's for prediction. What home value? So home value is Y. So they want to find Y with a input T. So T would equal to 2010 is time. So 2010 minus 1950, because when we use T equal to 0 at 1950, everything is relative to this, so that would equal to 60. That means you would need to find the function for Mississippi. We almost can write the function for Mississippi, right? Because we know the rate is 924. So it's mx plus the y-intercept. Y-intercept is when t equals 0. We have it, 25200. So we don't need to use point slope form. If you want to, you can too. But it is faster that way. So we have the Mississippi function, and we just need to plug in 60. So f of 60 would equal to 924 times 60 plus 25200, and if you put in the calculator, 80640. So in 10 more years, is the median home price will increase to 80,640. Pretty cheap compared to California. C, if the linear trend continues in the past and the futures, that means they're always continuous linear. Then the two-state income, when are they equal? So now I have these, the function for, so maybe I'll use this. The function for Mississippi is f of t 924.2520. Do I have the function for Pennsylvania? So maybe I'll use the space here. I have some. Pennsylvania's function is f of t is equal to their rate is 1092t plus the initial rate at what 1950. They start at 42400. So instead of 252, they have 424. Right. So this is Pennsylvania's home price function. So when will they be equal? So you just equate them, right? They're two different ones. So you want to solve the equation at 924t plus 25200 is equal to 1092t plus 42400. You might worry, would they ever be equal? Because this is growing faster, they start off faster. So let's see what happens. So to do this, I combine like term. So 25200 equal to 1092t minus 424t plus 42400. So so that means 25200 equal to 1092. Did I solve it? Where did I solve it? So that would be 168t plus 42400. I subtract 4240 on both sides, right? So I would have minus 42400. Just solve a linear equation. So 168, they are a little complicated because you're dealing with big number, but it's the same thing. Negative 17, 17200. Yeah. And then you divide by 168. So t would be divide 168, divide 168. That would be a negative time 102.4. So if you go back 100 years or so, they are the same. They would have the same median home price. So what would that year be? So our zero is 1950. So it's not that there's no solution. You would just have going back from 1950 for 102.4. So the number of year would be at 1847.6. So at year, so maybe I'll just here, at year 1847, they have equal house price. I think it's just hypothetical because housing price is never kind of linear. They change in different way. So let's look at the third, the last example, example 6. We will use it to model total cost. This is actually, I make it the last question example, but actually it's the easiest one because in this one, we're doing a basic cost function where I have doing a cost function, but it has basic cost given and a per unit cost. So the per unit cost, a basic cost to manufacture N shirts is 25,000. The unit cost per shirt is 6. So this obviously is rate, right? This is rate. So M, this is already rate and it's fixed. So it is linear. And this is our basic. So even if you don't manufacture anything, you have to pay this. So this is kind of like the y-intercept. So you can write it out really easily by saying, oh, that is equal to 6n mx plus 25000. And then you can use it to solve question like B. If you want to do, oh, how much does it cost to manufacture 3,000 shirt? What is the cost? Right? So what you do is you do C of 3,000 and plug it in and get the answer. Okay. So it's pretty straightforward.